Hello everybody. In this video we're going to discuss changing in tandem. This is going to be an important idea over the entirety of this course, as we're going to frequently consider how one variable changing affects how another variable changes. In this video it's important to think about how one variable is driving another. So just a few examples of what we may be exploring. We could possibly consider how money spent on advertising might drive total sales. We would expect that as we spend additional money on advertising, the total sales would go up. Perhaps we want to consider how time spent driving affects our distance traveled. As time goes on, if we're driving in a car, we would expect distance traveled to increase. Perhaps we want to explore a relationship in nature, like how the temperature outdoors might affect the number of chirps for crickets. In all these instances, though, we want to consider how our input variable is driving the output variable. We often think of this relationship as independent and dependent variables, but mathematically speaking, and in our course, we're going to think about the input variable driving the output. We're specifically going to represent this in three different ways. We can think about a point where our input variable will always come first and our output variable will come second. A table where our input variable is the left-hand column and the corresponding outputs would be in the right-hand column. And most importantly, and perhaps the best way to represent these types of relationships where one variable is driving another is with a graph, where the input variable is represented on the horizontal axis and the output variable is represented as the vertical axis. So I wanted to look at one specific scenario and talk about how the same scenario can be represented graphically in two different ways if we change what we're considering as the input and output variables. So let's consider a car entering a highway. If this car enters a highway from a complete stop, we want to sketch two different graphs. One graph where we consider time spent driving versus the distance the car has traveled. And a second graph where we consider again the same input variable, time spent driving, but versus an output variable of the speed of the car. Let's consider distance traveled first. We know time is our input and distance is our output. Let's choose specific units. Let's let time be in minutes. And our output be distance traveled. So the units here are miles. What do we expect the car to do as time moves on? Let's consider our axis. Let's look at time from 0 to say 4 minutes. And the miles, the output from 0 to let's say 5. If we think about the car at 0 minutes, it has not started moving yet. So we're starting from the origin 0, 0. At 0 minutes, we've gone 0 miles. As the car begins to move and as time goes on, we would expect the distance traveled to increase. As time goes on, the distance the car has moved will continue to increase. Let's consider the same input axis, time, from 0 to 4 minutes. But now we're changing our output. Our output is in speed, how fast the car is traveling. The output units, if we're considering speed that we're most familiar with vehicles, are miles per hour. This axis is going to behave differently. We're not considering distance traveled, we're considering speed. We know the average speed of a vehicle on a highway is 70 miles per hour. If we think about the speed of the car, before it begins moving, the speed is 0 miles per hour. Once the car begins moving, the speed is going to rapidly increase. But at a certain moment of time, once the car reaches the speed limit, the speed is no longer going to increase. Once we reach 70 miles an hour, the car will maintain that speed. When considering these graphs, it's important to think about how the output changes as we move left to right on the input axis. As we move left to right on the input axis, the inputs are increasing. We want to consider how the input increasing will drive our output.